Geometric progression. So what is actually geometric progression? A geometric progression is a number sequence such that the ratio between a term and its preceding term is a constant. The constant is known as common ratio. A geometric progression can be written as AR square, AR cube until AR to the power of n minus 1, such that the first term A equals to T1 also equals to S1. Common ratio R is equals to Tn over Tn minus 1, and the nth term Tn equals to AR to the power of n minus 1. Now let's try example 1. Given the geometric sequence 8, 16, 32, 64, and so on and so forth. Okay, next you need to find A, the general term, and then B, find T9. Okay, so from the given sequence, we know that A, the first term, is equals to 8. And then, in order to find R, you can use the formula of T2 divided by T1, which is equals to 16 over 8. Or, you can use T3 divided by T2, which is 32 over 16, which is equals to 2. Now, in order to find the general term, you can use the formula of Tn equals to AR to the power of n minus 1. So now, just substitute all the information where A equals to 8, and then your R equals to 2 to the power of n minus 1. After that, you need to change 8 into base 2, where 8 is equals to 2 cubed, 2 to the power of n minus 1. And then, simplify, you will get 2 to the power of 3 plus n minus 1, and that gives you 2 to the power of 2 plus n. So this is your Tn. In order to find B, which is T9, you just use this formula because we already have the general term. Therefore, T9 equals to 2 to the power of 2 plus 9. Okay, also equals to 2 power 11, and then use your calculator, you will get 2048. So this is your answer for T9. Example 2, the nth term of a sequence Tn equals to 2 over 3 to the power of n minus 1. A, show that it is a geometric progression. In order to show a sequence is a geometric progression, you need to show common ratio R is a constant. Recall formula of R equals to Tn over Tn minus 1. We already have our Tn, where Tn equals to 2 over 3 to the power of n minus 1. Now, we need to derive Tn minus 1. In order to derive Tn minus 1, you need to replace n with n minus 1. Therefore, you will get 2 over 3 to the power of n minus 1 minus 1. This is equals to 2 over 3 to the power of n minus 2. So this is your Tn minus 1. Now, just substitute your Tn and your Tn minus 1 into R. This is equals to 2 over 3 to the power of n minus 1 over 2 over 3 to the power of n minus 2. This is also equals to 2 over 3 to the power of n and 2 over 3 to the power of negative 1. And for denominator, this is equals to 2 over 3 to the power of n and 2 over 3 to the power of negative 2. Cancel out 2 over 3 to the power of n. And then, this is equals to 2 over 3. Since your R is equals to 2 over 3 and is a constant, therefore, a sequence is a geometric progression. B, find the value of n where Tn equals to 256 over 6561. We know that A equals to 1 and R equals to 2 over 3. And then, since Tn equals to AR to the power of n minus 1, and you are given Tn equals to 256 over 6561. Therefore, 256 over 6561 equals to 1 multiplied by 2 over 3 to the power of n minus 1. And then simplify, you will get 256 over 6561 equals to 2 over 3 to the power of n minus 1. Now you need to change 256 over 6561 into base 2 over 3. Therefore, 2 over 3 to the power of n minus 1 equals to 256 is 2 to the power of 8 and 6561 is 3 to the power of 8. If we have a to the power of m over b to the power of m, this is also equals to a over b the whole thing to the power of m. So apply that one, you will get 2 over 3 to the power of 8. And on the left side is 2 over 3 to the power of n minus 1. Since our base is the same, which is equals to 2 over 3, therefore, by comparing n minus 1 equals to 8, therefore, n equals to 9. Now let's look at the sum of geometric progression. So the first one is the sum of the first n terms. So the formula that we will use is Sn equals to a multiplied by 1 minus r power n over 1 minus r, for r is not equals to 1. So remember, this is the formula that we will use in our syllabus. The second one is the sum of infinity. Okay, so you can determine the sum of infinity by using the formula of S infinity equals to a over 1 minus r, where modulus r is less than 1. So what does it mean, modulus r less than 1? It means that S infinity only valid for r in between -1 and 1 only. Example 3. Find S5 of the GP in which A equals to 27 and R equals to 2 over 3. So first, you need to find S5. Okay, so recall, what is the formula for Sn? For Sn equals to A multiplied by 1 minus R to the power of n over 1 minus R. So this is the formula for Sn in GP. Now, since we have A equals to 27 and R equals to 2 over 3, you just substitute into the formula. Therefore, S5 equals to 27 multiplied by 1 minus 2 over 3 to the power of 5 over 1 minus 2 over 3. And then simplify. So when you simplify, you will get 71 over 3. So you just use your calculator, okay? Alright. Example 4. Calculate the sum to infinity of the series 2 plus 1 over 2 plus 1 over 8 plus 1 over 32 plus triple dots. Okay, so in order to solve this question, okay, so first you need to find sum to infinity. So sum to infinity only exists in geometric progression. So we know that from the given series, A equals to 2. And then your R common ratio is equals to, you can calculate by using a T2 divided by T1 or T3 divided by T2, which is equals to 1 over 4. And then recall the formula S infinity, which is equals to A over 1 minus R. And we need to check whether your R in between -1 or and 1 or not. Okay, so because this is the condition for S infinity. Okay, so since our R is 1 over 4, which is lies between -1 and 1, therefore the S infinity is exists, and now we can substitute the value of A and R into the formula of S infinity. So 2 over 1 minus 1 over 4, and use your calculator, you will get 8 over 3. Example 5. Express each of these number as a quotient A over B. A, we have 1.6 bar. 1.6 bar meaning 1.6, 6, 6. So 6 is repeating. And then B, 5.459. So if you look at the question, 5 and 9 contain bar. So this is equals to 5.459, 5959 triple dot, meaning that 5 and 9 are repeating. In order to solve 1.6 bar or 1.666 triple dots, okay, so first step you need to write as a series, which is equals to 1 plus 0.6 plus 0.06 plus 0.006 plus triple dots. Okay, and then we know that here is a series where you can calculate S infinity. So from this series, we notice that A equals to 0.6 and the common ratio R is equals to 0.06 over 0.6 equals to 0.1. Therefore, we have 1 plus S infinity also equals to 1 plus A over 1 minus R. And then substitute the value. A is 0.6 over 1 minus 0.1. And then calculate, you will get 5 over 3. Now let's try example 5b, 5.459 bar, or you can write as 5.4595959 triple dots. So first is you need to write in a series. So in order to recognize the series, you need to check which numbers are repeating. So in this case, 5 and 9 are repeating. So therefore, the series are 5.4 plus 0.059 plus 0.00059 plus 0.0000059 plus triple dots. And we notice that this is sum to infinity, where A equals to 0.059 and then your R is equals to 0.00059. So I take this one and then divide by 0.059, which is, if you calculate, you will get the common ratio equals to 0.01. Okay, so now rewrite, we have 5.4 plus S infinity. Okay, which is also equals to 5.4 plus, recall the formula of S infinity, A over 1 minus R, and then substitute all the values, which is 0.059 over 1 minus 0.01. And then by using your calculator, you will get 1081 over 198. As a summary, in geometry progression, A equals to T1 also equals to S1. Common ratio R is equals to Tn over Tn minus 1. The nth term is equals to Tn equals to AR to the power of n minus 1, or Tn equals to Sn minus Sn minus 1. Sum of the first n terms, we only use one formula, which is Sn equals to A multiplied by 1 minus R power n over 1 minus R, for R is not equals to 1. And the last one is sum to infinity, where the formula is S infinity equals to A over 1 minus R, where R is in between 1 and negative 1.